am here to discuss the very important topic of computer network, and that is the network layer and the IPv4 header. Actually, IPv4 is an inter-networking protocol that works at the network layer. Okay, that provides the logical addressing format for the source as well as destination system. Okay. Myself, Dr. Santosh Kumar, Associate Professor in CSC Department at AKGEC. So let's discuss the network layer. As we know that in ISO SI model, there is 7 layers, and in that layer there is a third layer that is known as network layer. Okay, network layer. Network layer. Basically, that is the third from the bottom. Okay, that means physical layer at the very bottom. There is a physical layer. Then above the physical layer, there is the data link layer. And on top of data link layer, there is a network layer. And that's why I'm saying that this is the third layer from bottom. Okay. So this network layer is concerned with the delivery of packet across multiple networks. Okay. So as we know that the work of physical layer is to change the data into the signal form, into the 0-1 form, and that raw data is transmitted from source to destination by using different type of communication medium. Okay, like twisted pair, that may be fiber optics, that may be satellite communication. And data link layer, the responsibility of data link layer is to hope to hope delivery of the data, and the major responsibility of data link layer to check the error and to control the error in the data. Okay. So network layer is responsible of delivery of the data from source system to destination system across multiple networks. Okay. So network is considered the backbone of the OSI model. Okay, this is the backbone of the OSI model that lie in between at the third layer from the bottom. It selects the manages the best logical path. Okay, so major role of network layer is addressing. What is the meaning of addressing? That means to select and manage the proper path, proper route from source to destination. When we say proper route, what is the meaning of proper route? Proper route means the route that has the minimum delay. Okay, there is the shortest path that takes minimum time to deliver the data from source to destination. So this is known as routing. Okay, so routing is a very important role of network layer. Routing. There are a number of routing protocols that work at this network layer. Routing means this is the process by which some protocol, some algorithm select the best path from source to destination and that deliver the data fast. So this layer contains hardware devices like router, bridges, firewall, and switches, but it actually creates a logical image of most efficient communication route and implement it with a physical medium. Network layer protocols exist in every host or router. Okay. The protocols that work at the network layer that reside at every router, okay, at every host. The router examines the header fields of all the IP packets and that pass through it. What is the role of the router? Router, when a certain datagram comes, certain packet comes toward a particular router, the router examines the header, okay, header of that particular uh, packet, and then decide some action that should be very appropriate. So the OSI model, the network layer responds to request from the layer above from the layer. Okay, like what are the layers that lie on the above of, on top of network layer? So that is the transport layer, then session, then presentation, then at the topmost, that is the application layer through which the user interact with the system. Okay. What are the major responsibilities of network layer? Very important. What are the major responsibility of network layer? So first one is the packet forwarding or routing of packets. Okay. So first very important roles of network layer is to forward the packet from source to destination to multiple hosts, to multiple routers or the systems. So relaying of data packet from one network segment to the another network segment in computer network. Okay, that is the routing of the packets. Let me decide the best route, route or path. This is the connection-less communication. Internetworking protocol, that is IP, is connectionless. Okay, what is the meaning of connectionless? Connectionless means there is no prior establishment of connection, because when we say the connection oriented, that means there is a three step that should follow. First, there is no three-way handshake. First, connection establishment, then data transfer, then third, closing of the connection. But here, no need of the connection establishment. This is known as connectionless. Connectionless. Okay. So connectionless services is not uh, that is that not ensure the delivery of the packet from source to destination. Okay. So a data transmission method used in packet switch network, in which each data unit is separately addressed and routed based on information carried by it. That means in this case, there is no logical or physical connection from source to destination, that is reserved for all the packet. Okay. Here, each and every packet have the source and destination IP addresses, and each and every packet may follow different paths. Okay, that is available at that time, and that is free at that time. That is best at that particular time period. So each and every packet follow the different path from source to destination. Okay, and at the destination, each and every packet are you know received in out of order, because you know that each and every packet. Suppose this is the network. Let's see the case. Suppose this is the network. We have taken a small network for example. Okay, like this one. Yes. Yes. This is the network. Okay. This is the source. This is the destination. Suppose, and number of hops are there between source and destination. Okay. Suppose source generate the packet, and one packet follow this one. Packet P1 follow this route. Packet P2 follow this route. Okay, and same packet 3 maybe P3 follow this route. Okay, that means source, the data at the source is divided into number of packets, and each and every packet has the source and destination addresses, and each and every packet follow different paths. Okay, so I'm saying that this these packets may deliver out of order. That means they will not deliver in sequence. What is the reason? The reason is very clear. Because it may be possible this P1 is follow this path, this one, and P2 follow this path, P3 follow this path. It may be possible that when P3 come at this one, is this node, and this is delivered very fast to the T. But P1 somehow between the communication stuck, or that is means that stuck in the congested path. Okay, so that is delivered first, P3 is delivered, then P1 is delivered, then P2 is delivered. This may be case because each and every node, each and every packet follow different path. So each and every packet have a different delay from source to destination. It may be possible that P3 packet P3 received first, then P1 received, then P2 received. Because different packet follow the different path, and different path have a different delay. Okay. So this is the connection layers where packet may be received in out of order, in out of sequence. Fragmentation of data packet. This is also the responsibility of network. When the data is large, that cannot be managed by the this bottom layer like data link layer. Because after network layer, data must go to the data link, and data link cannot process so large data. So for that, network layer divide the data into different small packets that is manageable and that can be treated as processed by this data link layer, bottom layers. So there are the two types of network transmission techniques: circuit switch network and the packet switch network. Okay. In circuit switch network, a single path is designated for transmission of all the data packets, whereas in case of packet switch, each and every packet will follow the different path from source to destination. Okay, so there are the two types of transmission technique. Circuit switch. In circuit switch, there is a logical circuit is reserved for all the packets. All the packets follow the same path from source to destination. In packet switch, each and every packet follow different path from source to destination. Okay. So in circuit switch network, the data packet are received in order, whereas in packet switch network, data packet may be received out of order. Okay. Because there is a circuit switch means there is a logical circuit from source to destination that is reserved. Okay. Each and every packet follow the same path. It is very clear. The packet which come first, which are transmitted first, that deliver first, and the packet which transmitted later, that is delivered later. The same path is there, no? So this is why in packet switch data deliver out of order, in circuit switch data deliver in order, in sequence. The packet switching is further subdivided into virtual circuits and datagrams. Okay, let us. So these are the short introduction about the network layer. Now we come at the IPv4. That is a very important topic of this network layer. V4 means version 4. Okay, so IPv4 is a connection-less protocol used for packet switch network. Which type of network? Packet switch, not for the circuit switch network. Packet switch, where each and every packet may follow different paths. Okay. So IPv4 give the source and IP addresses to that particular packets. It operates on the best effort delivery model, in which neither delivery is guaranteed Okay, nor proper sequencing is guaranteed. Okay, so because this is the connectionless, it does not guarantee the delivery of packet as well as does not guarantee sequence, yeah, in order delivery of the packet. So Internet Protocol version 4 is the fourth revision of the Internet Protocol and widely used protocol in data communication over different kind of network. IPv4 is, as we know, that connectionless and that is used in packet switch network, where we use this in packet switch layer network like Ethernet. Okay. It provides a logical connection between network devices by providing identification for each device. There are many ways to configure IPv4 with all kinds of devices, including manual and automatic configuration depending on the network type. IPv4 uses 32-bit address. Actually, this IPv4 uses 32-bit address space. Okay, for the Ethernet communication, and that is of, and these addresses are divided into 5 classes. Okay, and these are known as A, B, C, D, and E. Class A, B, and C have different bit length for addressing the network. Class D addresses are reserved for military, okay, and while Class E is reserved for the future use. Okay, so basically this IPv4 uses 32-bit address logical addressing. That means 32-bit means this IPv4 generate 2 to power 32 address different addresses. Okay, when 32-bit is used, it is very clear that total number of addresses generated by this IPv4 is 2 to the power 32. Okay, and IPv4 addresses are written in dot decimal notation, which comprises of 4 octets of the addresses, like this one. Okay, 192.168.2.3, like this one. This is the first octet. This is the second one. This is the third one. This is the fourth one. Each of 8 bits. So 8 into 4, 1, 2, 3, 4 is equal to 32. This is known as dotted decimal notation. Okay, these are the decimal values of first octet, then the next 8-bit in decimal, then the third 8-bit in decimal, then the last 8-bit in the decimal. And that is represented into decimal format. This is known as dotted decimal notation. Now, here we have to discuss IPv4 header. Okay, IPv4 header. Here, each and every protocol, when we talk about any protocol like TCP, IP, IPv4, then there is a fixed format of header that have the predefined different fields, and these fields is used to take the decision during the communication and during the transmission of the data from source to destination. Okay, so here we can see that this is the IPv4 header format. Okay, so we can see that there are how many rows? First rows, second rows, third row, fourth, fifth, and this is the fifth row actually. Okay, and this is the one more options. And each row have the 32 bits. If we see here, 32 bit now, from 0 to 31 bit. That means 32 bits. This is also 32 bits, 32 bit, 32 bits, and this is 32. Okay. So 32 bits means how many bytes? 4 bytes. Am I right? This is a 4 byte because each byte contains 8 bits. Okay, 8 bits. So this is the 4 byte. This is the 4 byte, and this one is also 4 byte. Again 4 byte. Again 4 byte. Okay. So this is the 4 byte each and every row is contained here. First row have some different fields. Okay. Second row is also have some certain fields. Third row is also of the some certain fields. Fourth and similarly fifth rows also have the fields. Okay. Let us see what is the meaning of these fields. This is the version field. Very first field is the version field, and this consists of 4 bits. That means first 4 bits is of reserved for the version. Version means what is the version of this internet protocol? Certainly this is the version 4. So the value of VER will be 4 here. Always 4 for the IPV4. Then next 4 bit is for the header length. HLength means header length. Header length. Okay. Next 8 bit is of service type. Okay. Which type of service is required by this for this packet? Okay. That is specified by the 8 bit, and that known as service type. Then the next 16 bit reserved for the total length. Total length means what is the total length of this datagram. Okay. What is the total length of datagram that have the header like this? Total length means that is the header length plus header length, okay, plus payload. Header length plus payload. Okay, payload means actual data that you want to transmit along with the header. Okay, because each and every packet which have the data is attached with some header. Because header is the information that guide, that provide the guideline, that provide the rules for the transmission of that particular packet from source to destination. Okay. Then when we talk about the second rows, so second row basically that is reserved for fragmentation. This is reserved for fragmentation. Fragmentation. Second row information is reserved for the fragmentation. What is the meaning of fragmentation? That means large data is divided into number of fragments. Okay. So these are the identification number. That is of 16 bit. Then next 16 bit is divided into 2 parts. First 3 bit for the flags that provides some control information that is used by the router. Meanwhile, the communication. Then the 13 bit is of fragmentation offset. Okay, fragmentation offset that means you can say that tells how many bits ahead this particular, how many fragments ahead of this particular current fragment. Okay, 13 bit. This is the offset. Then we come at the third row. In third row, first 8 bit is of field known as time to live. In short, this is also known as TTL. TTL. Very important field. Okay, each and every packet have this field. Time to live. That means this is the field that gives some number and that decide how much time, for how much time this particular packet will be live, and after this that will expire. Okay, so this is a very important field to to avoid the congestion, because once the particular packet is not delivered within time to live, within the time, then that will be discarded. Okay, so that that cannot move further in the network and unnecessarily create the jams and congestion. So time to live, then protocol. Next 8 bit is the protocol. Which type of protocol is this? Okay, like ICMP, IGMP. Okay, so different type of protocol is specified by this one, and then in third row, last 16 bit is for header checksum. As we know that checksum, the role of checksum is to check the error. Okay, so this information ensure or check whether there is some error in the packet in the header or not. Okay, so that is decided by this header checksum, that check the error in the header. Then this fourth row of 32-bit for source IP address. Source IP address of 32-bit, and the next fifth row of 32-bit destination IP address. Okay, this is the destination IP address, because it is very crucial field. This is the packet switch network where IPV4 is used, where each and every packet follow different paths from source to destination. So there must be source address and destination address at each packet, so that meanwhile the communication, okay, intermediate different node or router can forward to appropriate link, to appropriate route toward the destination. And this last field is of option plus padding, and this is of 0 to 40 byte. So this is not a mandatory field, but above these 5 fields are mandatory that must contain the information. This options plus padding is optional, that may or may not. Okay, and that's why the length of this will be 0 to 40 byte. 0 means there is no option field present in this particular datagram. Okay, so that vary from 0 to 40 bytes. So when we see the datagram, so this is the whole datagram where there is a header with payload. Payload is the actual data what we want to transfer, and header is the control information along with that payload. Okay, that assists different router for the delivery of the packet from source to destination. So as we know that the size of header is 20 to 60 byte. Why 20 to 60 byte? Because we know that there are the 5 mandatory fields, 5 mandatory rows, each of 4 byte. So 4 into 5, how many byte? 20 byte. Okay, so 20 byte, minimum 20 byte will be the length of header. But this option is also there, that may be 0 to 40. So that's why the minimum size of header will be 20 and maximum will be 60. Maximum when all these 5 fields are also there, and this option field of 40 byte is also present. So 20 plus 40, how much? 60 byte. So that's why the range of this header size is 0 to 20 to 60 byte. And this is the payload. This is the total length of the datagram. Okay, that may be from 0 to this 65,535. Why this one? Because we know that total length is of 16 bit. That means total length will be 2 to the power 16. 2 to the power 16. Okay. And that will be 65535. Okay. So that is the total length of the datagram. That may be, but it may be possible that some control packet is only contain the header information, payload is 0, and that case the datagram size will be minimum size, and that will be 20. Okay, so thank you all.